here, what does that minus out in front do to the graph? Reflect over the x-axis. So just like with quadratics, it's the same rule there. What about the minus 4 under the radical? What direction is the minus? Yeah, right 4, and then the plus 6? Up 6. Okay, so that's pretty straightforward, yes? You can just list the transformations. So when I go to number 2, we still need to know how to list the transformations, but this time we're making a graph, all in kind of like one step. So what does the 3 in front do to your graph? Vertical stretch by 3, so it's getting taller. What about the negative under the square root? Yeah, reflect over the y. And then the minus 8 means you're going to go down 8. So when you make this graph here, you work point by point. Now, I did not give you the parent function this time. So if you need to graph the parent function on the grid, that might be helpful for you. You start at the origin, then you have the point 1, 1, 4, 2, and 9, 3. If it helps you to plot those points so that you can see where you start from, then by all means, graph the parent function. And I'm going to have it there just so we can reference it. If I am taking my point here at the origin, and I vertically stretch it, does it go anywhere? No. I reflect it over the y, that doesn't move. But when it goes down to 8, the starting value is at 0, negative 8. Okay, so the origin point really doesn't move unless it's going left, right, up, or down. Right. So when I take this point 1, 1, when I transform that by stretching it by 3, where does it go to? What ordered pair? 1, 3. It reflects to the left over here over the y-axis, and then down 8 would be at negative 1, negative 5. If I stretch 4, 2, where does that go to? 4, 6. If you change the y by 3, so 2 goes up to 6. I flip it over here to negative 4, positive 6, and down 5, negative 4, 1.
How did you get
down 8, not 5, sorry.
How did you get the red line?
The pink line is the parent function.
What?
That's your parent square root. The square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3.
Oh, I did this.
2, 4 is for the parabola. We're doing the square. The parent function here is y equals the square root of x. All right, so for 4, 6, we go to negative 4, 6, down 8 would be negative 4, negative 2. Yep, then we stretch this to 9, 9. Flux over here. Down to negative 9, 1. So those graphs, we will have some on our practice here, but you need to be able to transform all the points there. So the purple one is the final answer. The pink is where you started from. What is the domain of that purple graph? We start from negative infinity and you go until 0. Alright, and the number part, the endpoint always has a closed bracket. What is the lowest y value here? Negative 8, and the graph goes up to infinity. Okay, so 1 and 2, really not that challenging. Compared to 3 and 4, have a little bit more work. So you have to remember a couple things. We're finding the domain of the square root function by hand. We're going to write the domain in set notation, and then we're going to sketch a graph. All right, so what do we know? How do I find the domain when I'm given the equation of a square root function? I said it greater than the radicand, which is 3x minus 6. I set it greater than or equal to 0. So I set up an equation here. Now what I'm going to do is I'm going to solve for x. So I start by adding 6, which is 3x is greater than or equal to 6, and divide by 3. If I didn't do it here, but if I were to divide by a negative, what would I have to do to the sign?
Flip it.
Flip it. But here I don't have to flip it because I divided by a positive. So that's the inequality I got. X is greater than or equal to 2. Now if I write the domain, typically it doesn't say here to write it in set notation. But if I were to write it in set notation, remember that's where you have the curly brackets. We've done a lot of that. And all you would write is your domain. X is greater than or equal to 2. Now we want to sketch a graph here. All I know is let's do it again. Our graph is all the x's that are 2 or bigger. Now we know, based on the last graph, that a general square root function kind of goes off to the side. So from this domain, we can make a sketch that's going to go that way. Right? That's what we expect the graph to look like if we were to graph it based on the domain. Right? That one's not that challenging, but the bottom one, you need to be careful because this is the one where we bring back in that quadratic inequality thing from the last unit. So we start off the same way. You take your radicand and you set it greater than or equal to 0. Now when I look at this, it's not the same solving process as it was on the last problem. I can't just add and go. What do I have to do here in order to solve this? Factor. I'm going to factor by GCF here. So here I'm going to pull out a 5x, and what's left inside? Yep. All right, well, I have a quadratic is greater than or equal to 0, so once I factor it, when I set each factor equal to 0, that's going to give me the roots of my quadratic. Okay? So I get one solution if I divide it by 5. One solution is at 0, and the other solution is at 4. Now that helps me a little bit. I know that I'm going to have a root here at 0 and a root here at 4 when I graph my equation, but I need to figure out what this graph looks like. Alright, so remember the other day in our notes, we off to the side drew our own little parabola. We have to draw a parabola in order to figure out how to draw our square root function. And if I have a root at 0 and a root at 4, and I suggest that we draw a picture for these so we can visualize it. Does this parabola that I have, does it open up or down? It opens up. Right? We have a positive leading coefficient. So when I open up here, I want to know where my graph is greater than or equal to 0. Which are these two little tails of my graph right here. Right? There's two parts of my graph that are above the x-axis. So that means when I write my domain, it gives me a hint as to how to write the inequalities here. So this left arrow, the left green arrow, what inequality do I write for the domain for this portion? You want all the x's that are less than or equal to 0, or this portion where all the x's are greater than or equal to 4. That's the domain of this square root function. So when I make my graph for less than or equal to 0 from that x-intercept, I go off to the left, and from this guy, I go off to the right. Now I want to caution you here because I'm going to suggest that you start with these problems when you get to your practice in a second. How would, this is not on your paper, but what if I had given you the equation negative 5x squared minus, or I'll do plus 1. So you would get the same roots when you factor. Okay, so I still get x equals 0 and x equals 4. But what happens to my quadratic that I graph because it's negative in front? It would be upside down, right? So we'd have this parabola. So what would happen to my solution set where I'm greater than or equal to 0? How many parts of my graph are greater than or equal to 0? 1. So if you were to sketch your square root function, if I had a negative in front, where would I make that square root graph? How would I make it? In a half circle. Yeah, Faith and I did this. That's actually the picture that you get for the sketch of your graph, because it's in between those two x values. So I only show you that because they may show up, and you might have to be able to carefully, don't just go out. You need to actually interpret what the domain is saying to you, okay? So what we're going to do today, the rest of the time,